After the tone, please state followed by the pound sign.
WebEx series that we have going on here. And this is a relatively lightweight segment. What I really wanted to do was to go through at a high level and summarize everything we've talked so far. We've had 4 segments so far, and the first one, we talked about platforms 1, 2, and 3 in general. And then the rest of them were actually focused quite a lot on day in the life of the developer, what platform as a service is, etc. As you might imagine, this series is largely centered around the 3 core themes that we have as a federation: platform as a service, cloud, and technologies around data lake. And that's really what the focus is. In this first 4 or 5 was mainly on platform as a service. So there was a good bunch of focus on Cloud Foundry. And I just wanted to review those ideas before we move on into cloud-type technologies over here, right? I should mention that on Ted Sakach's request, we've actually made a YouTube channel. This is the link below to it. It's a bit.ly link, and it's EMC Young Mind, and this is case sensitive. So if you go here, you'll see the first 4 videos uploaded there already, and they are openly accessible, including the QA. I've not personally edited that. Somebody else took it, and somebody in corporate took it and uploaded it. So you're welcome to go there, but I'm also sending out a summary of the recording. So if somebody wants to view the original recording directly from WebEx, they're more than welcome to do that as well.
Oh, yeah.
All right, so with that being said, let's go and get started with this kind of summary. So, without going back into what Platform 1 and Platform 2 are, suffice it to say that, a lot of it is, our technologies, which we'll see again. So there's still the client and server components, there's middleware, there's programming languages, there's relational databases, there's all that kind of good stuff, which is going to continue to persist as we go to Platform 3 world. So it's really a fairly radical shift of what kind of use cases we see in this space. And the use cases are mainly social, mobile, big data, and cloud-based use cases, largely to take into account the tremendous number of users that we have who are both creating content as well as content consuming content.
How do you do what?
And the ability to do analytics with this content, but also the scale at which applications developed and the time to market that's key for corporations to remain competitive. So we started out this journey with an example of a seed company, right? I talked some about this, and just to motivate what's new about this Platform 3 thing to begin with. And as we saw, if I have a seed company, what these guys did was to actually take seeds, and they were able to derive from these seeds the genomic sequence for the seeds, which by itself is a big data problem. And they knew a lot about seeds because they said that, well, if the seed were to be planted in some kind of a field somewhere, then that field would in fact, the seeds would thrive in a particular microclimate and a particular type of soil if only they knew what this soil was. So what they decided to do was to say, let me marry the genomics data from the seed and actually move that wirelessly through a satellite or some kind of mobile communication over here, that let's move that data over to the enterprise and use this as machine-to-machine data, and to be able to manage the soil condition, the humidity, etc., and match that to the seed information they get from the genomics. So this is a classic big data analytics problem, right? And this is the kind of problem they wanted to solve. They literally wanted to build a data lake which had all the data in here. And by the way, they use Hadoop technology quite extensively in this mix, and they use a whole bunch of other structured data analytics as well. The end result was, in the words of their CEO, was to solve world hunger. And quite literally, that's what they want to do, because they figure that if they actually match the seed to the soil and the microclimate in a particular farm, then they could probably increase the yield of that farm, or maybe even be able to plant seeds in areas where it was tough to find anything that would grow there, and increase the productivity of this of the food cycle worldwide. So when they tried to do this, they realized that they needed to move very rapidly, and they had to do a lot of stuff. And they acquired a company which actually had a footprint in the data analytics space with the climate systems. And they were already actually developing on Amazon. So they had a cloud on AWS, which they were developing on, and that's how they wanted to get very rapidly, functional. What we went to them and said was, listen, we can significantly improve your time to market if you run platform as a service with Pivotal Cloud Foundry on Amazon. And what that will let you do is give you time to build an internal cloud on vBlock and run Pivotal CF here, and be able to move the data from one cloud to the other without changing your application. And this is a tremendous value proposition. The fact that you can develop anywhere and move the data any way you like, that's just absolutely amazing. And then with that, of course, is all the other technologies that come in the data lake, Gemfire for rapid ingest of streaming content from machines in the field, Hadoop for analytics, maybe Greenplum for analytics, RabbitMQ for messaging. All of those kind of things really come together in this whole mix. So this is the kind of solution that many of our customers are looking at, and they want a federated technology stack that's going to take them there. And that's really, for us, that's the monetization path to the third platform, is a lot of machine-to-machine data, a lot of mobile technologies. You can see this is all mobile, big data technologies mixed in it, and cloud technologies to get this kind of application portability between an external and an internal cloud, so you can actually hybridize it. So to understand what all this means and why and how to actually, build a solution like this was where we spent the rest of the sessions over here, is to understand what is it that's so attractive about this thing called platform as a service. As the whole idea of doing platform as a service was that you would get rapid time to market. So we started to look and see, okay, how do we get rapid time to market? But to do that, we needed to understand what's there in the day of a developer. What does a developer really see? And now, developers, they write code. And so to understand what happened in the day of a developer, we needed to understand to some extent what code writing is really all about. So, the traditional way so we cover software development life cycles, SDLCs as they call, and the different styles of being able to write software, and what some of the positives and negatives were with each one of them. The style is known as waterfall, right? Now, what waterfalls type of methodologies did was, it's quite literally, that's what it looks like. It's a waterfall. You got your design, you got your requirements first, and then you got a design, and you went through the whole cycle till you actually deployed. And it was a linear process. You started out with all the requirements in the beginning, and over a several month time period, you actually came to something that you could deploy. There was very little interaction with the end user through this whole development process. So it took a long time, and often the end user would come and say, well, that's not what I wanted, and they would say, come on, that's what you said, and well, there was a miscommunication and something happened. So not that waterfall techniques are bad, but if you start with 50 requirements and you develop the 50 requirements, then it takes a long time to get here. Now, in contrast, what people have done is they've looked at some more modern methods of development called Agile, and we talked about Agile too. And how does Agile really differ in this whole mix is you start with not all 50 of your project outcomes. You put those 50 in a pile called the backlog. So that's where my 50 are. But what you take on is something smaller, which is, say, the top 5 requirements that your software needs to have. And then they go through a rapid and iterative cycle where they develop. The cycle is typically 2 to 4 weeks. And in this cycle, they do daily code reviews, and each is a commitment. They build the code every day. This daily code review is called a Scrum. And this one here, this 5 of these is called a sprint. And this is called a backlog. All right, now what happens is that as they go through the cycle, you produce usable code very, very quickly. And this is usable, runnable code because you're building it all the time. The only thing is it starts with only 5 features. But these are the most important features, so it's able to do most of what you want it to do, but you're doing it in a fraction of the time. And then you incrementally take the rest of the features into more sprints, and you go through the cycle and you keep augmenting this code. At any given time, you can interact with the customer directly, and they know exactly what they're getting, and they can always revert back and change anything you like. So Agile has really gotten very popular in software development methodologies, and this is pretty much one of the ways that we help our customers, because we have, you know, our Agile, the name for Pivotal comes from Pivotal Labs, right? And there's nobody as good as these guys in teaching people Agile. Both Pivotal Labs as well as Extreme Labs, which is a little more geared towards extreme programming, which is very often used in mobile technology development. Both of those are part of Pivotal, and they are the, I would say, the front runners in this kind of development methodology. And many of our customers are eager to absorb this and get really good at it. So we literally take our customers' programmers, bring them in-house, and we train them. And they come with a project, and we make sure that they finish their project. And they see what the output is, and then they go back and they start to develop that way. Twitter, Google, a whole bunch of companies like that are customers of Pivotal, as was Greenplum, which is when we realized who they were, and we decided that we should really work with them. But closely related to this whole question of how you develop is, how long does it really take a development organization to marshal the resources which are needed? It brings us to a very interesting little spot here with another thing that we discussed in our Young Mind series so far is this idea of DevOps. So what is the whole world about DevOps? I mean, so we established developers write code. They do it in either waterfall or agile type methodologies, and then they want to actually deploy the code. Now, to deploy the code, they need to create what's called a runtime environment. So if it's code in Java, there's a Java runtime environment. If it's code in Ruby, there's a Ruby runtime environment. And somebody's got to build it. It's software that needs to be installed and configured and made ready and stuff like that. And then somewhere you have to connect with the data. That is, you have to marshal the data services that are available. Where is the data? Is it in a Hadoop store? Is it in a SQL database? Is it in a key value store? I got to bring the data in this picture. And then someone has to build the operating system on a virtual machine, on a server, with a network, and with some persistent storage under it. This whole process is a real time killer. And this is one of the biggest reasons why time to market for companies is really, really bad. So people will write code, and then they sit and wait for weeks, sometimes months, until everything is built. And this may just be to test your code. When you actually want to deploy it into production, then you need hardened systems. You need to be able to scale it. You may need 10 copies of the application or 100 copies of the application. Not at all easy. So this is where, generally speaking, we work with platform as a service, which does this bit, and this part is typically what's called infrastructure as a service. So you start to go cloud-like in these dimensions, and you say, all I should really have to worry about is the deployment of the code. By the way, this whole thing of, hey, what are the software packages I need? What are the dependencies between these software packages? What version of operating system? What patches? That whole process is called DevOps. The dev in there being how do I build the system, and the ops being how do I operationalize it. So how do I do release management, etc. So you may all have heard of terms like chef in your customer shops, or Puppet. So these are really what are called, these are DevOps tools which will help automate all of these steps over here, which a platform as a service would do. And in conjunction with an infrastructure as a service, this is how you really sit and develop this whole thing. So, you may say, well, okay, well, that's all nice and fine. So where does, the seed company story fit into all this, and where does platform as a service fit into all this, and what does EMC have to do in being able to help us do any of this kind of stuff? So what we do to take this a step further, what we had to do then was to understand, hey, what's the language, and what is a framework? And what is the relationship between these two, and how does one help in what we want to do? So the simplest way I'll look at it is, a language is what you use to really specify the business logic. Now, in reality, a language is used for everything. It's used to build the entire application. And a language, we've talked about many languages, and we've talked about the differences between things that look like a language and things that are actually a language. We talked about Java and Ruby and Fortran and C and C++ and COBOL. We also talked about pseudo languages like HTML and SQL, which really don't have flow control built into them, so those are not languages. But eventually, they are the workhorses to get done what you need to get done. A framework is sort of like a helper. I call them the plumbers of the software world. And we looked at the analogy of building a house and saying that, while our interest may be how to get electricity to a lamp over here so I can actually light up something by plugging it into the wire, there is a framework which needs to bring in the wire from the mains and actually do the wiring through the 2x4s in the house and all that kind of stuff, and that is really the plumbing. So think about frameworks as doing something very similar. That the business logic is, how do I get power to the lamp and power it on so I can have light in the house? The plumbing that needs to happen before that can happen is the house needs to be built, the foundation needs to be laid, the power needs to be brought into a circuit box and distributed out, the right voltage in the right place, all the safety code has to be followed. That's really the plumbing. Much of programming happens with almost everything being done by the business logic. This is akin to you sitting and building your own house. I mean, it can be done. I was a general contractor for my basement. I'm not going to wish that experience on anybody else. But I definitely don't want to do framing and plumbing. I can guarantee you that. I'd much rather have an expert do it. So what frameworks do is they help to code just the business logic in the language and let the framework take care of everything else. So we talked about several of these frameworks. One of the most well-known frameworks is for the language Java. And the framework which usually corresponds to that is something called Spring. And Java and Spring are a match made in heaven. We own Spring from a federation standpoint. Spring is open source, but we acquired Spring Source a while ago. VMware acquired Spring Source a while ago. It's now part of Pivotal. So another common framework, very popular framework also on web-based applications, language is Ruby, and the framework is Rails. And there's a slew of these which will basically do a lot of the heavy lifting. And to illustrate all this, what I'd done was to give you a simple example of a piece of code written in Ruby, which I used another not so well-known framework called Sinatra to be able to develop a simple application and to show you what can really be done in deploying applications with this, something like this. And if you recollect, if you go back to segment 3 and watch the videos there, I demonstrated writing a Hello World program, running it locally on my Mac, and being able to get to the Hello World through a web server running on my Mac. And all I really had to do was to write the Hello World. Sinatra, the framework, did everything else, right? Then we said, well, just deploying an application locally with a framework isn't enough. I really need this to be more of an enterprise application, something that everyone can access, not just me sitting on my Mac on my local port. So that's where we came to Pivotal Cloud Foundry. And what we had done was to illustrate how this might work. So I sat on my Mac, and we did this demo, and I'll show this demo to you one more time so it's fresh in your mind. I should tell you that the demo is very effective with most people. I've shown it to customers, even seasoned development teams, and they absolutely love it. So I wrote code, and I deployed the code to a web services portal from Pivotal. This is the free account that you get when you go to Pivotal Web Services, and you can sign up for a 60-day trial. And what I literally did was to take that code and deploy it on the fly. All I did was write the business logic, and I got a fully running web app on the Pivotal Web Services Cloud. Another demo, which I wasn't able to show you, but I will show you in subsequent sessions, is how we can easily take the same bit of code and run it on Amazon Web Services, which also would have a copy of Pivotal Cloud Foundry running on it, right? This is the power of this whole solution, which means all I do is I write code here, and I deploy an app here where a complete third party, such as yourself, is able to access it. So just to illustrate this point, let me kind of show you what I really mean by something like this, right? So in this case, I've written a simple app, and I've shown this to you before. This is something called, Sinatra test. So it's called, it's a file called st.ruby. It's a very simple file. And all it says is if I go to / so I go to the get/do, says if I go to the top level for the application, I get a hello world. And if I go to /info, I get more info on hello world. And then if I go to /form, then I get a couple of new things over here with get and post. And I've given a much more detailed explanation of this on the Segment 3 webcast, so please go ahead and have a look at that for more details. And I'll be happy to share the code with you. This is, as you can see, it's a totally simple program. So now, having written this code, and I've shown also how to run it locally, I can say, let me try to push it to a cloud. And so I use Cloud Foundry, and I look at the target, and I've already set the target before, and this is actually on the external Pivotal Web Services cloud. So I have a path over here called api.run.pivotal.io, and I have a target app space called development in an org called Curtic-org, and I'm the user. So I'm going to do something very simple. I'm just going to say push this application, and it reads a file called a manifest, and it creates an application called ST, which is Sinatra test, and it says, I'm going to bind that application to this URI, and I'm going to now upload this application, and then I'm going to do some of the really painful stuff, which most developers have had to do manually till now. And what was that? They had to prepare the environment. They had to find storage, a network, a server, a virtual machine, have someone install an operating system for it, go and install all these gems, and then install all these packages, bundle everything together. And all of this is what really killed people's time. So if you notice right now, I'm not doing anything. All this work is being done by the Pivotal Cloud Foundry Platform as a Service solution, and it builds something called a droplet, and bingo, that's all I had to do. I now have an application called ST, which is available at hk.cfapps.io. So let's go and look at this URL. So I say hk.cfapps.io. So let's look at cfapps.io. Bingo, I get hello world. So what I'd like you guys to do is, if you got your mobile phones, go ahead and go to this URL, hk.cfapps.io, and you should be seeing the same thing as me. If I go to info, I get more info on hello world. This is exactly what we had in the code that I showed. So my time from writing code to actually deploying an application that you, in your offices or your homes or your cars, well, hopefully you're not doing this in a car, can fire up a mobile device and take a look at this application is almost instantaneous, because this is now a worldwide available application running over here. Now, if I go to form, we come to, again, the application that I showed before. This actually gives me something to interact with it. So, by the way, Paz is the name of an Easter egg coloring company. So that's what I've used as a logo here. And I can submit, say, any phrase over here, like crude. And if I do that, and I click, and you should be able to do this on your web browser on your mobile device as well. Type in anything you like, and all I have is my two favorite people, Beavis and Butthead, repeating back what I just wrote, which is prove. Right? So the point is, guys, this is really the power of Cloud Foundry, which means I wrote code and I deployed the code onto Pivotal, and this is you accessing that on your mobile device. And the entire time it took for this was roughly about a minute or so. This is unthinkable in a world where you actually got to go back and look at all of this stuff. When you got to do all of this, this takes weeks and weeks and weeks. And now what we've done is, and even with infrastructure as a service, even with Chef and Puppet, it's very, very hard to do this and scale. And that's the other thing that Cloud Foundry can do. It allows you to scale. Just like I pushed one copy of that data, I can now push 10 copies of it, and all 10 of them will start up. So this is the essence of what I want you guys to understand at a high level about platform as a service. I did do one more segment 4, where I went into quite a bit of detail into the architecture of Cloud Foundry and how actually Cloud Foundry does its magic through, you know, the cloud, through the cloud director, through the dynamic router, to BOSH, which is a layer that talks to the infrastructure, and all of those kind of details I provided to you. The fact is that we can run Pivotal Cloud Foundry on virtually, not on virtually any, but on several of the major infrastructures as a service, and that includes anything that supports vSphere, so the vSphere APIs, the vCloud APIs, and this is coming up in another couple of months. Any OpenStack deployments, as well as Amazon Web Services. So you could deploy on a private cloud, you could deploy on an external cloud, and you can deploy the workload in one or the other pretty much from wherever you have your code. And that's the amazing thing that people love about this. They have to do none of the DevOps that's actually involved in this, right? So what Pivotal Web Services does for us is all the painful and onerous things that I had to rely on human beings doing, which is to build my runtime environment, to bind with the data, to build my operating system, my VMs, my server, my network, and my storage, and all of that you saw done in front of your eyes, right? So take that message, guys. This is a simple enough thing to do, and get with your customers and talk to them about these kind of things. It's absolutely critical that the message get out, because this is an absolute game changer for most of our customers. Are there other platforms as a service? And we discussed this in segment 4 too. Absolutely. There's, you know, Red Hat has OpenShift. Heroku has been very mature out there, and Google App Engine is there, Microsoft Azure, all of those kinds of things are there. But what this does is a multi-framework capable system, which is deployable on-prem as well as off-prem, with a very rich ecosystem around it of all the other technologies that surround the data lake. Right? This is why we have one of the most powerful portfolios in the business. This is what we need to constantly and consistently talk with all our customers. So this is a very quick summary of what we have covered so far. I hope this was useful and lucid. I want to switch gears after this one to start to move into infrastructure as a service, and I'll start by next time by doing a demonstration of how Amazon Web Services really works. And what I had to do to get an EC2 account, to start to fire up machines over there, to install Cloud Foundry on it, and to actually be able to use that as a target for the applications that I wanted to deploy. And I think you'll get a sense for why our customers like AWS so much, and why the whole idea of a well-orchestrated, well-run hybrid cloud makes more sense now than ever. But we'll dive into those technologies later. So let me stop and pause for questions. I did not mute the line. Thank you very much for your discipline in not in not making too much noise. I really appreciate that. So I'm going to open up my chat window and see, see if anybody has any questions. So other than Dan McKenney's question saying, hey, use *6 to mute everybody, I don't see any other questions. But our lines are open. I haven't muted anybody, so by all means, feel free to ask any question. As always, feedback on any of this material is very, very critical for me, so we can constantly start and improve this. And I intend to keep the, I intend to keep uploading these videos onto the YouTube link that I have over here on EMC Young Mind on Bitly. This points to YouTube. And any other topics or any other suggestions, I'll be more than happy to oblige. Does everybody think this is a sufficient introduction to Cloud Foundry and to DevOps and all that kind of stuff? Is there anybody who thinks we should get more detailed or less detailed? Is this too overwhelming?
Forrest.
Yeah, go ahead, Forrest.
Hey, good stuff as always. I think to answer your question, anytime we can get a little deeper as we kind of crawl along here is always going to be a good thing. So, I encourage all of my peers and the SEs and even the AEs that are on the call. If you want more detail, you got to get carded to feedback.
Yeah.
I have a question though. In our area, we've done a little bit of the CF stuff earlier in last quarter, which was great. The question that kind of pops in my mind can you describe a few of the customers that are already CF customers and users outside of the Monsanto story that you come across?
Yeah, I'll have to think about that a little bit, because once again, I want to sort of be careful that I sanitize as much as I say here, because this is on an external portal. But yes, there are.
It's always kind of fun to drop a name here and there about customer A was doing this and customer B was doing that, telling those stories.
Yeah. Some of the most well-known customers were well-publicized. Biggest is Baidu, which is kind of the Google of China. They do almost all their stuff completely on Cloud Foundry. Another great customer, again, this is a publicly known customer. There's a fabulous video on YouTube, which I strongly encourage that all of you guys look at. It's called, the thing is labeled From Zero to Factory. And this is by the CEO of Time Warner. and it's a $3 billion company, and they basically got rid of all proprietary software in their entire shop. In fact, they got rid of all relational databases in the whole shop, and they run everything exclusively in Cloud Foundry. Very inspirational story, and this is it's pretty stunning. They do even financials and closing books, and just about everything they do on NoSQL. It's certainly, customers like that make it tremendously inspiring for us to start to look at people like that. So look for this one on YouTube, and I think you'll get a much better feel for what some of our customers are doing. I'll be happy to get you a more sort of detailed list. This and the other customer, of course, I said was Baidu. Right? There's plenty more, and in our division itself, I'll look around. I know that several people are starting to work on it, so I will see how I can sanitize those stories and share with them. Okay.
Hey, Kartik. Hey, it's Mike. How do we quantify the savings provided by Cloud Foundry? What are the main factors? Number of apps, number of bindings. What should we be looking for?
The biggest value here, I'm presuming that's Mike Lepori?
Yeah, it is.
Who is that? It is? Okay.
Yes.
Hey, Mike. The biggest kind of positive here, Mike, is really time to market. Okay, if there's any one reason our customers are going to cloud technologies, be it Amazon or Azure or anything, it's because it takes them too long to go through the DevOps cycle to actually test and deploy any new set of applications. This is particularly true in rapidly moving spaces like mobile, where you iteratively develop a lot of applications. You may deploy, test, discard, deploy, test, retest, scale. Those kind of scenarios just don't work too well when you're trying to do stuff in-house. So what Platform as a Service does is it gives them complete independence from what the underlying infrastructure is. All they need to know is bind to the right data services. They can fully leverage frameworks to improve their development time to market. But most importantly, they are not waiting on infrastructure to provision. So that's one benefit. The other benefit is scale. I can scale very easily. It's one thing to build a system for one application, but if I want to build 10 systems for the same application, regardless of how nice your infrastructure as a service is, that takes time and effort. So they're able to scale and shrink on demand in Cloud Foundry. And the third and the biggest sort of benefit that Cloud Foundry has is the ability to achieve cloud portability. I am not locked into any particular deployment of Cloud Foundry. I could do it in-house on a private cloud on a vBlock, like some people said, or on an external cloud provider like Amazon, if that's what I choose to. Or more recently, vCloud Hybrid Services is also going to be supporting it. So now I can move between clouds. And I think that's the other sort of big kind of benefit too. Your application, you're not going to save any money by saying, hey, I'm going to use Cloud Foundry, because it's going to need what it's going to need from an infrastructure standpoint. It's going to need a certain amount of memory and network and access and all that kind of stuff.
Yeah, I thought you mentioned that it's much faster, and I'm wondering.
Yeah, that's correct. It's time to market is faster. An application is an application. What it does is it speeds up the time to deployment.
Yes. So what do we need to do to measure that? How long it takes them to deploy today is what should we be asking for?
Yeah. How long does it take to deploy today? The ease with which you deploy today, the ease with which you can deploy at an external cloud provider like Heroku or AWS, and that's what we need to sort of benchmark against what we can achieve by using Pivotal CF. So they're good questions. I mean, I have yet to develop a full sort of ROI TCO model for what this is. I'm sure one exists and more exists. So I will get in touch with the Pivotal guys and see if they can articulate what the financial kind of benefits are. But the intangible benefit is actually the greatest one. Agility. That's really all about what it's all about. Any other questions, guys? Okay, we're all good. We can wrap up. Once again, thank you all for your support and constantly looking for feedback on anything I can do to improve this or add more content. As I said, I'm sensitive to the level. I know both sales and SEs are on this call. If you want me to go lower or higher, that's, I'll try my level best to accommodate. If the SEs feel that they need even deeper drill downs, I'll be happy to do that as well. And we can go with that. All good? Any last gaspers? All right, folks, thank you very much. Really appreciate this. Bye.